Hello guys, welcome to the next video of the machine learning models algorithms. Now we have completed the supervised machine learning algorithms. Now we come to the unsupervised machine learning algorithms. What is unsupervised ML? We know that in unsupervised ML there is no dependent feature. There is no dependent feature. We try to make clusters or group, cluster or group based on similar kind of data. Okay, this is unsupervised machine learning. In unsupervised machine learning, the first algorithm we will learn, that is the k-means clustering. Okay, what is k-means clustering? Now we'll see. In k-means clustering has various steps. So I will first write the steps of k-means clustering, then I will explain to you. First is get the k value. Get the k value. Second, initialize k number of centroids. 3, calculate Euclidean distance. Number 4, compute average to update the centroid. Okay. For getting the k values, we use one method known as elbow method. Okay, to get the k values. K means what? K means clustering that k value. Okay. Now we'll do here. K means it's a parameter and it is also termed as centroid. Okay, centroid. K also termed as centroid. Now first, k means clustering means based on the centroids we will try to cluster. Okay, so don't confuse it with k nearest neighbor. It is an unsupervised ML model. Okay, first is get the k value. How to get the k value? This is my data point. Suppose these are my data points. Okay, these are my data points. First I initialize k equal to 1. First I initialize k equal to 1. I suppose I make k over here. K. Okay, k over here. I try to calculate the distance between these points. Okay, I calculate the distance. Next I initialize k equal to 2. Suppose k is here, I calculate the distance. Okay, now from here I try to draw another graph. See, here the k values and here WCSS, that is the distance. That is the distance we have calculated. WCSS is the distance. What is this full from? I write over here. Full from is within within cluster sum of square. This within cluster sum of square, that means this distance only. Okay, and these are my k values. So when k equal to 1, I calculate the distance and make it an average. My points comes here. When k is equal to 2, my point come here. like this. Now if I try to join this, it will become a shape, and this shape is known as elbow curve. Elbow curve. Elbow curve. And here in the elbow curve, where I find there is an abrupt change, so this becomes my K value. So I got the K value by elbow method. I initialize the K, calculate the distance, try to draw a graph between the WCSS with the cluster sum of square and K. I got an elbow curve where there is an abrupt change. I take that K value. Here is an abrupt change, I take the K value. So first method is over. Now, second, initialize K number of centroids. Initialize K number of centroids. So suppose my data point is this. Now this is my data point. I initialize the K number of centroid. So I suppose K comes to be 2. K is 2. I initialize 1 over here and 1 over here. Okay. I initialize that K number of centroids done. Next, calculate Euclidean distance. I tried to calculate the Euclidean distance between these points. I calculate. Euclidean distance is calculated. Next, compute the average. I compute the average of this Euclidean distance to update the centroid. I computed this average. Next, I repeat the same methods again. Initialize K. Now my K comes here. This K comes here, like that. I try to move this several times, the centroids. Next, the value, we calculate the average. Which average comes to be less or the most accurate, we take that there, the centroid. Suppose after doing that, my original centroid comes over here, original centroid comes over here. By calculating the averages, we update the centroid from here to here to here. We see the average is come to be very accurate here. So we take the K here. So this forms, when this K, so this form my cluster 1 and this form my cluster 2. Okay. So this is K-means clustering. And K-means clustering also affected by the outliers also. Like same of that K nearest neighbor, the outliers also is affecting. So we get the methods. First we take this elbow method, the K value, initialize K number of center, initialize, calculate the Euclidean distance, compute the average, we calculate the average, then move the centroid, then again calculate the average, move the centroid, like where we get the accurate average, we place the centroid here and we make it as a cluster. So K means clustering is done. Next method of clustering is hierarchical. Hierarchical means clustering. What is this? I need to explain. Very easy. See, hierarchical means clustering. Hierarchical clustering. Okay. Hierarchical means clustering. Okay. Hierarchical means clustering. I try to draw the points. Suppose my 1 point is here, 1 point is here, 2 points, another 2 points is here, another here, some points is here, some points is here. Okay. So this become my point 1, point 2, point 3, 4, 5, 6, 7. Okay. So my points become like this. Now I will take these points, make it into small clusters. Hierarchical means small clustering. Small clusters. From small we will go to the big. Small clusters. Small clusters. I have taken the small clusters. Now what I will do, I will try this. I will convert this from by drawing the cluster. Next I will draw another graph. Okay. And this graph. See, I have the data points 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. Okay. See, 1 and 2 are my pairs. I draw this 1 and 2. Okay. 1 and 2. 3 and 4 is there. 3 and 4. I draw. What is this? The distance. What is the distance between 1 and 2? 3 and 4, like this. These are the distances. 1 and 2 distance, Euclidean distance. 1, 2, 3, 4. 5 is nothing, and 6 and 7, like this. We calculate. Next, after that, we try to make it small, bigger clusters like this. I can make it, yes or no? So 3, 4, I convert it into 5. So this becomes my another cluster. Okay. I then try to make another again cluster. Okay, like this 1, 2, and 6, 7. So 1, 2, 6, 7 is mix. Then I try to make the total. I take then small coming from small, then little bit of big, like this. This is hierarchical means. That means the total, that is 1, 2, and total I take. Okay, the total I take. Now this graph is known as dendrogram. This graph is called as dendrogram. It's called as dendrogram. This is called as dendrogram. Okay, like this we are drawing. Now how to find the k value? Sorry, not k value, the how many clusters are there. We will draw a line. We will draw a straight line such that it is not a straight line. It is not. We need to draw a straight line or the longest line such that no horizontal line passes through it. No horizontal line passes through it. So I see this. This becomes my straight line such that no horizontal line passes. No horizontal line. It can be here. It can be here also. It depends. Okay. So here. So if we see that if this graph is here, if the line is here, longest line, such that if longest line is here such that no vertical, no horizontal line passes through it, like this, we cannot draw clusters like this. Okay, we cannot draw. We have to draw like such that no horizontal line passes through it. We see that 2. So here you see that 2 clusters are present. 2 clusters. Here if we find 1, 2, 3, 4, 5, 6. But it should be what? Longest. What I told. Longest. Longest is this. So 2 clusters. Answer will be my 2 clusters. I can form like this one and this one cluster. So 2 clusters. So this method is called hierarchical mean clustering. We need to draw a dendrogram. From the dendrogram we need to draw what? Longest vertical line. I write it here. You need to draw a longest line that has no horizontal line passes through it. Full stop. So this is the main. And that no horizontal line passes through it, that will give my clusters. The intersecting points give the cluster. Intersecting points gives the clusters, the number of clusters. Very important. Huh? Intersecting points gives the number of clusters. This is called dendrogram. Okay. Next method is density-based spatial clustering of application with noise. DBSCAN clustering. DBSCAN clustering is a very big concept, and if we want to apply some cluster models in any of the algorithm, we always use DBSCAN method because it is the best clustering model which gives the highest accuracy. For this clustering model, we need to get some important points we need to know. First is epsilon. Second is minimum points. Third is core points. Fourth is border points. And fifth is noise points. Okay, so what are this? I will explain to you what is epsilon. Okay, see, suppose this is my data point. This is my data point. I try to draw a circle. I try to draw a circle between this data point. Okay, I draw a circle. Okay, I draw a circle, and this radius is called my epsilon. Epsilon. This is my data point. What is the epsilon? The radius. If you try to draw a circle, so epsilon is clear. The radius. Minimum points. If I this is my data point, these are the points here line. So these are my minimum points. This is my parameter. This is my minimum points. So minimum points clear. Next core point. What is the core point? If I draw a circle, okay, this is my data point, this is my radius, that is the epsilon. I have 4 minimum points, 1 2 3 and 4 minimum points I have. These are my minimum points. My data point is my epsilon. If I have 4 minimum points inside the circle, so this data point is known as core point. This data point is known as core point. Okay, so core point is clear. Data point, this is the radius, that is the epsilon. If I have 4 minimum points, then this is the core point. 4 points inside a circle, 4 minimum points inside a circle. Next is the border point. What is the border point? If I draw a circle here, okay, suppose this is my core point and this is the data point, this is the radius. If I have one core point inside a circle, if I have one core point, this is a core point inside a circle, then this point, the main data point, is known as the border point. Border point. So border point is clear. If I have a core point inside a circle, this is known as the border point. And noise point is what? If I try to draw a circle. If I try to draw a circle, this is my point. There is no minimum point. It's empty. So this point is known as noise point. This is known as noise point. So noise point is clear. So epsilon is the radius. Minimum points is the number of points inside a circle. Minimum points. Core points. If the 4 points inside a circle, 4 points inside a circle is known as the core point. Border point, if there is a core point inside a circle, is known as this border point. The main point, data point, is that border point, and the main data point is a noise point. When there is empty, circle is empty. So I will make you understand what is this density based clustering. We have understand these terms. Now how it will predict the clusters. Okay, that I will make you understand. So now how, if we see this figure, this is my main data point. Okay, I see these are the core points. If we see these are the core points, if there is one core point, so this is a core point inside, this is a core point, one core point inside the main data point. This is known as the border point. See, 1 2 3 4, 1 2 3 4, and the epsilon, this is the core point. So this is the noise because no data point coming inside, it is a noise. So minimum points is 4, epsilon is 1 unit. So in this is DBSCAN method of clustering. In this way we try to make clusters. Okay, using this core point, border point, we try to make clusters, and finally we get the result that how many clusters are present by drawing this. Okay, now if we see that there is a deep mathematical approach in this DBSCAN method, if we try to go deeper how these clusters are impacting, it will take time. So if you want, then I will make a video on this DBSCAN extra, the depth method. So now it is the basic things I have cleared. What is the border point, noise point, core point, minimum point, epsilon, and how it is predicting. So the basic things I think you have understood. Now next thing we will go is that performance validation or validation of clustering models. What is this? In regression algorithm, we find that in regression algorithm we have used two methods, R2 score and adjusted R2 score. In the classification we have used performance for calculating the performance accuracy, recall, precision. Okay, F2 score, F beta score, like that. Here also we have some performance model or validation of the clustering models. One of the method is Silhouette clustering. Another is RAD method is there that we not need to understand. Main thing is Silhouette clustering. What is this Silhouette clustering? Okay, what is this? The main thing we will see. First, take a cluster. So this is a clusters. I have my data point like this. Okay, another clusters I have. Data points are there. These are my data points in the clusters. First, I will calculate two distances. First distance is from here. I will take a centroid, middle. I will calculate the distance between the data points. So suppose I term it as A of I. Okay, A of I, and I calculate this distance, and my formula becomes A of I is equal to 1 by C minus 1. C is the number of data points. C, the number of data points. C minus 1 mod of C minus 1 average of distance. Distance I comma j. Distance formula you know, I comma j or x comma y. Anything that is root under x minus x2 minus x1, y2 minus y1. This is the distance. This is the distance. Okay, this is the distance. And this is my, I calculate the distance, I take the average, and this becomes my AI. I calculate the distance, and compute the average. Okay, now next thing is that I calculate the distance between the clusters, that this distance, this distance, this distance, this distance. So this becomes my B of I, and my formula becomes of the B of I is minimum 1 by C mod C. C is the data points, average of the distance, I comma j or x comma y. I calculate the BI. Okay, so AI I got, BI I got. how A of I got, B of I got. Now how to calculate the C score? Okay, for calculating the C score, we have the formula as A of I equal to B of I minus A of I, B of I minus A of I by max of A of I comma B of I. Okay, this is the formula. Now how to, from this calculator we get some value. Now how to calculate this, whether it's a good model or bad model? We see S of I equal to, first is that A of I, calculate the CLAVT score. Okay, this is the CLAVT value. This is the CLAVT value. Now, how to say that this model is a good model or a bad model? For that, we need to analyze A of I and B of I. If A of I is less than B of I, that means it's a good model. Good clustering model. Next is that if A of I is equal to B of I, is equal to B of I, then I can say that the model is somewhere in the middle. Somewhere in the middle. Not good, not not too good, too bad. Somewhere in the middle. And if A of I is greater than B of I can say that the model is bad model. Bad clustering model. Okay. So if anyone asks what is the CLHAUT value, I will calculate this. If anyone asks what is a good clustering model or bad clustering model, I will compute from A of I, B of I. How to get the A of I, B of I? A of I means take the centroid, calculate the distance, average it. This is my A of I, and B I distance between the clusters, B of I. So whether clustering model is good or bad, we have understood. Okay. So next we will see the practical implementation. Okay. After that, I think the some topic of dimensionality reduction is left that we will complete, and the machine learning series will get over. Then we will proceed to deep learning series. Deep learning is very easy than that compared to machine learning, and in deep learning we will do various the two main things, that is the multi-layered perceptron, that is the ANN, artificial neural network, and convolutional neural network. So deep learning series will come after we complete the machine learning series. So for that I need to have a motivation, so please like and share my channel, my videos, and if I see I am getting more motivated, then with the deep learning I will also upload the videos of the natural language processing. In natural language processing, the various LSTM, bidirectional LSTM, the text preprocessing, what to vector, okay, transformers, BART, then other things, analytical library, spacey library. Okay, I will give some extra videos on NLP then. So for that I need motivation. Please see to that, and thank you for today.